This video is about the semantics of the propositional language. In another video, we explore the syntax of the propositional language, namely rules of grammar that determine when a formula is grammatically correct or well-formed. Here, instead, we will explore how to assign truth value and meaning to the formulas, to the well-formed formulas of our propositional language. The general strategy to assign a truth value, true or false, to a given formula will consist of two steps. There will be a basic step where we assign truth value to the basic proposition P, Q, and R. So remember, these are the atomic proposition, and they are denoted by lowercase letters. And then once we have assigned a truth value to this basic proposition, we assign meaning to the connectives, negation, conjunction, disjunction, implication, and double implication. And this will allow us to assign a truth value to any formula of arbitrary complexity. First step is to create a valuation function. This is typically denoted with the uppercase letter V, so the valuation function V. And this is a function that assigns every atomic proposition, P, Q, and R, a truth value that can be 0 or 1. So in other words, what a valuation function does is to give to every atomic proposition a truth value. A truth value 0 is typically analog to the truth value false, and the truth value 1 is typically analog to the truth value true. One side observation is important at this point, namely that the valuation function V that we've just defined as assigning truth value either 0 or 1 to each atomic proposition encodes the so-called principle of bivalence. So this is the principle that says that every atomic proposition is assigned one truth value or the other, so that there are only two truth values in total, truth or falsity. There is no third possibility. You might want to think about whether this is a plausible principle or not. Let's see now an example of a truth evaluation function V. Evaluation function V for the atomic proposition P and Q. There are actually 4 possible valuation functions that we can define for two atomic proposition P and Q. So we have the first one, in which we assign 1 to both P and Q. The second possibility for the valuation function V2 is to assign 1 to P and 0 to Q. There is also a third possibility in which we assign 0 to P and 1 to Q. And then there is a fourth possibility in which the valuation function assigns 0 to both P and Q. So the valuation function is not defined once and for all. We need to define one, and if we have two atomic propositions, we have many possibilities, namely we have 4 possibilities. Now you might wonder, which valuation function are we supposed to pick? Are we supposed to pick valuation function 1, 2, 3, or 4? This is a question that lies outside the field of logic. So logic simply gives us all the possibilities, and observation or science is the discipline that allows us to find out what is true and what is false. This is not the business of logic. So insofar as logic is concerned, our choice of evaluation function for the atomic proposition P and Q will be simply a matter of stipulation. You might wonder at this point, how many valuation functions are there? Well, this depends on how many atomic propositions we are considering. If we are considering only one atomic proposition, then there are only two valuation functions. The valuation function that assign 1 to the atomic proposition under consideration, and the valuation function that assign 0 to the atomic proposition under consideration. There are only two possibilities. If we are considering two atomic propositions, there are a total of 4 possible valuation functions. This is the example that we just saw in the previous slide with P and Q. If there are 3 atomic propositions, then there are a total of 2 at the power of 3, namely 8 possible valuation functions. And I encourage you to write down all the possible combinations and convince yourself that indeed there are 8 possible valuation functions. If you want to generalize, then for n atomic propositions, there are a total of 2 at the power of n possible valuation functions. And once again, I want to emphasize the point that logic does not tell us which valuation function to pick. There are several valuation functions possibly available, and picking one rather than another is simply a matter of stipulation. Okay, so far we've only assigned truth value to atomic formulas. The valuation functions assign truth value to the atomic formulas P, Q, R, etc. They don't assign truth value to more complex formulas. So the question arises, how can we assign truth value to more complex formulas? Formulas that contains a negation, or they contain a and connective, or they contain the or connective, or they contain the implies connective. How can we assign a truth value to these more complex formulas?